Welcome to the history of modular arithmetic. It all began with a Chinese philosopher who was trying to solve this problem. So he was thinking about a number which gives a remainder 2 when divided by 3, it gives a remainder 3 when divided by 5, and it gives a remainder 2 when divided by 7. So 23 is the number which solves all these three equations simultaneously. So how he might have conceived this problem? Let's say he is just sitting in a market and he's thinking about how 23 mangoes will fit in a basket which can hold 3 mangoes, and another basket which can hold 5 mangoes, and another basket which can hold 7 mangoes, right? He might be thinking about something like that. Anyway, this was the first use of the remainder theorem in the recorded history. Then comes Aryabhatta. So he was studying the astronomical objects, right? The planets, the sun and everything. So how they revolve around the sun, the moon, their periods, their cycles. Okay, so they keep repeating the pattern. So the study of the repeated patterns. So there also the use of remainder theorem was observed. So So the best way for you to gain understanding of this is just by take a look at your clock. Okay, so let's just assume that right now the time is 1:50 p.m. Okay, and that's how the clock reads. Right? You can ask this question: what would be the time after the next 80 minutes? So in order to actually solve this problem, right? So what we have to do is we have to deduce what would be the hour and what would be the minute. Okay. So let's try to solve the minutes first. We don't actually have to count the 80 steps. So that when the minute hand, it takes 1 step, 2 step, and then it has to complete the 60 steps and plus the next 20 steps. We don't actually have to run through all the 80 steps, because we know that after the 60 steps it comes to the same position again. So we can just simply try to figure out what will be the minute after the 20 steps. Okay, so it will be at this particular position, right? And the hour hand will be exactly at 2. Okay, maybe slightly after 2, right? So that time would be 2:10 p.m. and then you can ask what would be the time after 26 hours. Okay, so the hour hand has to complete 12 steps, another 12 steps, another 12 steps, two 12 steps, but after every 12 steps, I'm thinking about hour hand, for hour hand, one step is this one big step. Okay, and the next big step. Of course, in the analog log, you can observe that the hour hand will be in between, but yeah, anyway, we should be able to deduce that the time after the 26 hours would be 3:50 p.m. Okay, so all we have to do is just add 2 to the hour here, right? 1 plus 2. We don't actually have to add plus 26 and solve it. Okay, so that's kind of the intuition. So then enters Carl Friedrich Gauss. Okay, so he publishes a book which is called Disquisitions of Arithmetical Investigations, right? So that's how it translates from Latin. So there he proposes this notation which reads A is congruent to B mod n. The meaning of this is when the number A is divided by n, it has the same remainder as when the number B is divided by n. Okay, let's assume that if the number n is 5, okay, and we can say is that 1 is congruent to 6, 7 is congruent to 12, okay, and 24 is congruent to 4, and so on, right? Because all these the congruence which I talked about has the same remainder when divided by 5. So this notation, this contribution in this book is very important because it is such a legendary thing. He was able to integrate the the middle school math with the early college math. Of course, the Chinese philosophers and the Aryabhatta, they were able to use the modular arithmetic without this notation, right? The same way that you studied about remainders, quotient and everything, okay, in your middle school without worrying about this notation. So this is the mythical, this is a journey of the number theory, this modern algebra, this group theory, field theory, everything. It started from the mythical astronomy and it is now used extensively in the modern cryptography. Okay, and I'm very thrilled for this course, and you're going to learn a lot, and you're going to really understand how these mathematical constructs are used in Bitcoin. Okay. I hope you join me for this entire journey.